How to solve polynomial equations. So far, we have explained how to find all rational roots of a polynomial p, x. In fact, they represent nothing more but the solutions of the corresponding polynomial equation p, x, equals 0. Hence, the procedure is also used to solve polynomial equations of whatever degree. The only restriction is that all coefficients and the constant of the given polynomial must be integers. Otherwise, the equation must be solved using the computerized methods. In short, all polynomial equations are solved by combining the rational root theorem and the synthetic division method, as explained earlier in this tutorial. Let's summarize everything through an example. Example A. Solve the following polynomial equation shown in the following on screen. B. Write all possible factorizations for the left side of this equation. Solution. A. Solving the polynomial equation means finding all zeros of the polynomial on the left side of the equation. The left part of this equation represents the third-degree polynomial. We have the following shown on screen. Where a, n equals 1 and a, 0 is equal to 6. From the rational root theorem, we know that all possible rational roots of a polynomial, if they exist, are in the form p over q, where p is a factor of a, 0 and q is a factor of a, n. The possible factors of a, 0 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, and those of an equals plus or minus 1. Thus, we obtain the following list of the possible zeros of the polynomial. We have the following shown on screen. After removing the duplicates, we can list 8 possible roots for the polynomial p, x. They are minus 6, minus 3, minus 2, minus 1, 1, 2, 3, and 6. Now, let's see which of them is or are the true zeros of the polynomial. Since the polynomial is of the third degree, we have 3 zeros at maximum out of 8 possible ones. Substituting each of them in the polynomial p, x, equals x cubed minus 2x squared minus 5x plus 6 yields, we have the following shown on screen. From the operations, it is clear that x equals minus 2, x equals 1 and x equals 3 are the solutions, roots, of the given polynomial equation, as only for those we have p, x, equals 0. B. We have to use the synthetic division method to find all possible factorizations of the polynomial on the left side of the equation. Obviously, we will consider only the already found roots for this purpose. Thus, using the coefficients 1, minus 2, minus 5 and 6 for the upper row and the roots of the equation on the left yields, for the root x equals minus 2, we have the following shown on screen. The numbers in the last row, except the rightmost one that gives the remainder, represent the coefficients of the long expression in the brackets. The other expression involves the zero of the polynomial. We have the following shown on screen. For the root x equals 1, we have the following shown on screen. The numbers in the last row, except the rightmost one that gives the remainder, represent the coefficients of the long expression in the brackets. The other expression involves the zero of the polynomial. Hence, we have the following shown on screen. For the root x equals 3, we have the following shown on screen. The numbers in the last row, except the rightmost one that gives the remainder, represent the coefficients of the long expression in the brackets. The other expression involves the zero of the polynomial. Hence, we have the following shown on screen. That is all for lesson 11.3.5, and the end of tutorial 11.3. To continue this chapter, please watch 11.4, Introduction to Rational Expressions. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.